All right, as we get going then, today you guys are going to appreciate today because as much as long division was, and the process is super long and drawn out and fairly difficult as well with the algebra. Today we're going to do something that's called synthetic division, which basically is long division, and you can think of it as long division without the variables. We get rid of the variables and we kind of go back to just using numbers. It is much quicker, much easier, but we had to kind of go through the long division part in order to get you to understand the reasoning for synthetic division. It was one of those, what I will call kind of a necessary evil. It's not something you're probably going to use very much going forward. I doubt you'll use it at all when you get to the test next week, okay, because you'll have synthetic division instead. But what I want to start off with today is, so that's the plan for today. Next week, Monday, Tuesday, then will be review days, okay, where we'll go over stuff in class. I'll give you kind of a review packet it's got some similar problems to what's on the test. General idea though is if I give you an equation, you need to be able to do kind of all the stuff that we've been working on. And that's why the worksheet that I gave you was a little bit of everything and not just long division. I was starting the process of reviewing on this worksheet, okay? Where long division is just a method of factoring is all it is. It's one of your methods, okay? So first question, or first thing, as we take a look at, or as you take a look at this worksheet, okay? I only gave you 4 problems, okay? And the long division, by the way, that's in the Delta Math assignment, that one you're just doing the long division. You're not fully, factoring it all the way through like we were doing the other day. You're just doing long division with what's given and then putting the answer down, okay? So you're just doing it the one time is all you're doing on the Delta Math. And I think I only gave you maybe 5 problems of those or something. I think that was all you had to do was like five of those. But if you take a look at this worksheet real quick, okay? Number 1 on the worksheet, if you notice, is a quadratic equation. So you can go through and you can fill out kind of all the stuff of how many zeros does it have, what's the degree, all that kind of stuff. On that problem, do I need to use long division? What do you think? Parker, what do you think? No. Because the point when we use long division is we're trying to get it down so that it's to a quadratic, so that then I can either factor or do quadratic formula. Okay? So number 1, you don't even need to use long division on that one at all. That one's back to like your quadratic chapter, back to chapter 4 stuff, where you're just finding the x-intercepts, whether it's quadratic formula, factoring, whatever. Those are methods. Okay. On number 2, on that one you might have to do it, but you're only going to have to do it one time. Okay. You'll go through, you'll plug in the cubic function into Desmos, and off of the graph, then you should be able to find at least one real zero, which then you can go through and do the long division with, like we did yesterday, or Monday. And then from there, you can go through again. Then you'll be at a quadratic. Your answer will be a quadratic answer, okay? The bottom 2 are a little bit longer. Those are the ones where you got to go through a little bit more in depth, okay? Is there any one of these that you want to go over together? I want to kind of open it up. Is there one of these 4 that you want to kind of work your way through? Or with me telling you that you're not really going to have to do too much long division going forward, are you feeling okay about that? You tell me. It's up to you. If you need help and you want to go over something, well, I'm more than happy to do it. Otherwise we'll move right into the synthetic division. Yeah, Naomi? Sure. Let's take a look at number 3. Okay. So if we put that one up here. Number 2. All right, so there is your problem. If we just start through, I'm going to kind of do everything but the x-intercepts. I'm going to just leave those to the end. I'm going to kind of do the rest of the worksheet. So step A here says What's the degree? So what is the degree of this function? Degree do we have? Yeah, what do we got? 4. Yeah, this is a 4th degree function, okay? Which tells me, and it's also a positive a value, okay? Which tells me right away that I know the graph is going to kind of have that W shape to it, okay? I know that right away. That's the general shape of this graph. Part B, how many total number of zeros do I have? Yeah, okay, 4th degree, 4 total zeros, okay? Now, I don't know right now how many are real versus imaginary. I need the graph for that, okay? But I know I've got 4 total zeros that I got to find. When it says to describe the end behavior, let's start with that. So that is as x goes to negative infinity, y goes to, well, if we know the graph looks like that, where's y going both at the start and at the end of the graph? Where are we headed to, Marissa? Yeah, both going up to positive infinity. Good. Okay? So, same thing here. As x goes to positive infinity, that means y goes to positive infinity. Okay? So there's the end behavior that kind of matches the shape of the graph is the idea. They then ask you to graph it on Desmos. We'll do that in a second. Okay, I'm going to skip that for now. And actually, I can't skip that. I gotta go through and I actually gotta do it. Because in order to answer the rest of the questions, we gotta have that. So, let me put that in Desmos quick. Alright, so if we put this in, x, 4th power, x, 3rd power, 8x squared, minus 12x, minus 240. And so now, if we kind of zoom out here a little bit, we know it's kind of that W shape that is what we're looking at. But if you take a look, I'm going to go zoom way out here. So far, it kind of looks like a parabola. But if you take a look, there's kind of there's your change right there. It just happens to be way the heck down here to get to that W portion, okay? And really, I don't care too much about what's going on down there. It's got the shape that we were talking about. What I do care more about is right in here. If I zoom back in, if you notice, there's one of my x-intercepts right there at positive 5. There's another one at negative 4. That's more what I'm focusing on. Okay, positive 5 and negative 4. So, let's go back to that. So, what does the general shape of the graph look like if I just sketch it? Well, it kind of looks like this, and then it went like that, and then it went like that. And this was at negative 4, and that was at positive 5, right there. There's your general shape of your graph. Okay? So now, we can kind of answer the rest of these questions here. Part E then says to describe where the turning points are. I'm going to have you just skip that. You can label it. I could go through and say, all right, here's a relative minimum right here. We haven't really focused that much on it, so I'm going to let you just go ahead and skip that. It's not all that important. So F says how many zeros are real. So we said in part B here, we said there's a total of 4 zeros. F is asking how many of those 4 are real, and what's the answer based on the graph? What do you think? All right, Connor, what's my answer? 2. Yeah, goes through at negative 4, goes through the x-axis at positive 5, so I know there's 1 in each spot. So I have 2 real zeros. Then if we take a look, it says how many, and how do I know? Well, it's right on the graph. Okay, that's how we know. We take a look at the graph and it's going through the x-axis. Then if we take a look at part G and ask how many of these are repeated zeros. And what's the answer to that one? Yeah, what's the answer to that one? How many zeros are repeated?
None of them.
Okay, and how do you know that one?
Because none of them bounce off them.
Yeah, they both of the x-intercepts that you can see go through the x-axis. Neither of them bounce off of the x-axis. Okay? So no repeated zeros because there's nothing that's bouncing off of the x-axis. Then the question is for part H, how many imaginary zeros? And what's the answer to that? How many imaginary? Yeah, if we've got 2 real and 4 total, that means we have 2 imaginary. Okay, we've got 2 imaginary zeros. And how do we know? Well, it's what's left. Okay, we already know that we've got 4 total and 2 real, so whatever's left has to be imaginary. So then it says to make a list of the known zeros, which we've got, it's on the graph, okay? Rewrite them as factors and prove that they're zeros using long division. So this is now where we go through and we kind of finish up the problem, okay? So first question I have for you, and I'm gonna go to the next page and we'll start doing the long division here. So first question I have for you, if -4 is my first zero, what's my first factor? First factor here. -4 is the zero. Parker, what do you think? How do I go from -4 on the graph to a factor? Not sure? Marissa, do you know? Yeah, it's always x minus whatever the zero is. Okay? Whatever the value is for your zero, it's always x minus that. So this would turn into x plus 4. That's one of my factors. And therefore, since this is a positive 5, this would be x minus 5. Okay? So we've got 2 factors, which means I need the other 2. Okay? I need a total of 4, so I need the other 2 in this case. So I'm going to go through and we're gonna do the long division. Okay? One quick thing that I'm not sure that I made clear the other day is kind of how do you know when long division is something you're supposed to use? Well, all the factoring we've done prior, if there was 2 terms, we said difference of squares, difference of cubes, sum of cubes kind of thing. If there was 3 terms, that's kind of your quadratic factoring that we've talked about. If there was 4 terms, that was the box method factoring by grouping. Long division comes into play if there's more than 4 terms. Okay, you got to get that down to at the very most, you got to get it down to 4 terms, and you might be able to factor, then you might not be able to. But that's when long division comes into play. Is if I've got more than 4 terms, we got to use that. Okay, so let's actually go ahead and do that. I'm gonna add a page here. Come on, smartboard. All right, let me add that x to the 4th back in. All right, so there is what we're dividing, and we're going to go through. And in this case, we said the first factor, it does not matter whether you use the x minus 5 or the x plus 4. I'm going to use the x plus 4 just because it's the first one that I wrote down. Okay, but it does not matter the order. In the end, you'll get to the same place. One of the other things I want to make sure that I mention now as well that I may or may not have mentioned before, if you notice here, we go from x to the 4th, x cubed, x squared, x, it goes down by 1 degree every time. If you are ever missing a term, let's say it went from -x cubed to -12x and that term wasn't there, you need to, if you're doing long division, or today when we talk synthetic division, you got to fill it in as like a placeholder. You'd have to put in a 0x squared there, okay? You didn't have to do it on the homework or anything, but I just wanted to give you a heads up that that's kind of coming as well. That if you're missing a term ever, you got to fill in a 0 whatever, 0x squared, 0x cubed for a placeholder as part of the process. All right, so now if we go through and we do the long division, it's just a couple of steps that we repeat over and over and over again until we go through the process. So first one is x times what gives me x to the 4th. In this case, we start off with x cubed. Okay? And then we take that and distribute it through the x plus 4. So when I multiply by the x, I get x to the 4th. Multiply by the 4, I get 4x cubed. And then We subtract, but I told you I think it's easier if you just add the opposite. Okay, so I'm gonna put plus and then add the opposite of all the signs on the bottom. Now all we have to do is combine like terms. Okay? X to the fourth, negative x to the fourth, those go away. Negative x cubed and negative 4x cubed give me a total of negative 5x cubed. We now bring down the next one, negative 8x squared. And now the whole process starts over again. That is the process right there. Once you bring something down, now we go right back to the x plus 4 again and say, all right, what do I multiply by to get that? So in this case, I need a negative 5 and I need 2 more x's. So it's a negative 5x squared. We again distribute through the x plus 4. That gives me a negative 5x cubed times 4 gives me a negative 20x squared. And once again, add the opposite. The x cubes cancel. The x squareds, I end up with a positive 12x squared. Bring down the next term, the minus 12x. And start the process again. In this case, we need to multiply by 12, a positive 12x. X times 12x will give you 12x squared. And 12x times 4 gives you a positive 48x. Again, I'm going to add the opposite. X squareds cancel out. Negative 12x, negative 48x. I put that together, I get a negative 60x. And then finally, we bring down the negative 240. And the last thing I'm going to multiply by is negative 60. Distribute that through, I get a negative 60x. Multiply by 4, I get negative 240. And sure enough, when I add the opposite on this one, the x's cancel, the 240s cancel, and there's my remainder right there of 0. Okay? Which we knew we should have got anyway because we already knew x plus 4 was a factor from the graph. Okay? We already had it, so I knew I should get a remainder. Now, here are your options going forward. Okay? Option number 1, how many terms do I now have? How many terms do I have? Marissa, how many do I have? Now I've got 4 terms, right? So what comes into play now that could be an option? How do you factor something with 4 terms? What do you use, Sophia? Yeah, the grouping, the box method. So now I don't necessarily have to keep going and do long division again with the other factor. You might have to. If the grouping or the box method isn't working, then you got to do a second long division with this part. But if you take a look, if I go through and I do the box method here, I'm going to put it off to the side. We've got an x cubed and a negative 60. 2 middle terms are negative 5x squared and a positive 12x. And if you take a look, now we start factoring. Okay, greatest common factor for the first column, we can pull out an x. Second column, I can pull out a negative 5. Goes into both of those. Then if we go rows, I can pull out an x squared. And here I can pull out a 12. And so if you take a look, what we actually end up having then was, we had that x plus 4 that we divided by. There's the x minus 5 I took off the graph right there. And then here's your other quadratic factor, the x squared plus 12. There it's factored. Okay? So in this case, you didn't actually have to do long division a second time because we were down to 4 terms. Okay? And now the rest, set h1 equal to 0. Here's where your 2 imaginary answers are going to come from. Okay? You set that equal, you're going to get the square root of negative 12, which if you reduce that, reduces to 2 square root of 3i. Okay? Let's go through that just for a second, just to make sure you're understanding that again. If I take this x squared plus 12, set it equal to 0, I get x squared equal to negative 12. And therefore, now when I take the square root, because I took the square root when I'm solving an equation, plus or minus, and now we're working on that. Square root of a negative, we automatically know it's going to be imaginary. Okay? So I can pull that negative, I'll do it off to the side here. I can pull the negative outside as an I, and now the rest is just reduced to square root of 12. So what's a perfect square that's a factor of 12? Perfect square that's a factor of 12. I don't know what goes into 12 that's a perfect square.
4.
Yeah. So this factors to the square root of 4 times the square root of 3. Again, I'll just bring the I along kind of for the ride. Square root of 4 is 2. And there's your 2 square root of 3i. So in this case, there it is right there. 2 square root of 3i. There's your 2 imaginary answers right there. X equals negative 4. There's 1 real 0. And x equals positive 5. There's your other real 0. So there's the 4 we were talking about. 2 real, which we saw on the graph, 2 imaginary. Okay? And the nice part about this problem is you really only had to do the long division once. You didn't have to go through and do it again. Okay? Making some sense, hopefully? These are hard, okay? I'm not gonna lie that this is a process. Okay, that's one of the reasons why I was talking to Mr. Fufal and Mr. Notsky yesterday or the other day, and I don't really enjoy long division. I don't even enjoy teaching it all that much because of the fact that it's such a long process that it takes so long to get to the end. Okay, but we got there, and like I said, today I'm going to give you a better method. Okay. So what I want you to do is I'm going to have you take out just kind of a sheet of paper or something you can take some notes on. Okay. Because I mainly have some examples for you today of how we can now go from long division to what is called synthetic division. Yeah. So here's what we're doing today. We're getting away from the long division, and we're going to now do it with synthetic division instead. Okay? And we'll go through the process. And like I said, the good news, this is so much faster and so much easier than what we just did. Okay? So here's the first one. We're going to take a look, and we're going to try to factor this cubic polynomial. With the given factor, I meant to change this to x plus 2. So factor the polynomial with the given factor using synthetic division. Okay? So here's our cubic function right here. And we are now going to factor that, not with long division, but with synthetic division. Okay? And we're going to take a look, and we're going to see. I don't necessarily even know that that's a factor. So that's another thing we can check for pretty quickly is to see if it's a factor. Now, I could go and graph this, but I want to do it mathematically as well. So one of the things, first off, when we set this up here, what I'm going to do is I'm going to put down I'm going to leave, again, in order, okay, highest degree. If there's anything missing, you got to fill it in with a 0, okay? And what we are going to do is we're going to divide that by the x plus 2, okay? So here's the idea. Here's what's happening. Now, if you remember at the beginning, I said we can kind of take the variables out, and we can go through and actually just use the numbers. So here I'm going to have a 1x cubed, a 4x squared, a negative 8x, and a negative 6. Okay? Get rid of the variables, just use the coefficients. Then the other part is, instead of using a factor, I'm going to actually go through and I'm going to use the 0 instead. Okay? So if x plus 2 is the factor, that means negative 2 is actually the number that I'm using. Okay? I'm going to use the 0 here when we do synthetic division. So here's the process. Okay? As we work our way through, bring down the 1. And you always bring the first thing down. Then we go through and we multiply. Okay, I take the 0 that I'm working on, and I multiply by whatever we brought down. I get -2 here. And then at that point, we add. 4 and -2 is 2. And now it's the same process. Multiply, add. Multiply, add, multiply, add. 2 times -2 gives you -4. Add those together, I get -12. Multiply, I get a +24. Add, I get 18. And that's the last number. Reason I put that number in the box, that's my remainder. If you were going to actually do long division, that is the remainder right there. Which tells me, by the way, is x plus 2 a factor of this cubic function? What do you think? Why not, Sophia? Yeah. If something's a factor, it has a remainder of 0. Okay? That was why that warm-up the other day, why we did the 36 divided by 9 was 4. It wasn't 4 1/3, 4 1/2, 4 1/4. There wasn't anything extra because it had a remainder of 0. It was a nice factor. That's what we're looking for. So this tells me right here that x plus 2 is not a factor of that cubic function. Okay? And notice, that's a whole lot faster than being able to have to go through all that long division to try to figure it out. Okay? So that's, this one I wanted to just give you an idea, just to see the process, the setup, see what's going on from there. Okay? Now, let's go into this. Let's take a look at this one. Okay? Next one. Back to this polynomial given x minus 9. So same thing again. I'm going to just bring the numbers down. So this would be a 1x cubed, a -18x squared, +95, and a -126. And if x minus 9 is the factor, what would be the 0 that I'm checking? What's the 0? What do you think? What's the 0 of x minus 9 here? Yeah, then we would be using 9. Okay? So here comes the synthetic division. Always bring the first part down. You got 1. And then multiply, add, multiply, add, multiply, add. 1 times 9 gives you 9. Add those together, I get a -9. Multiply, I get a -81. Add, gets me 14. Multiply 9 times 14, and correct me if I'm wrong on this one, but I'm pretty sure that's 126. Which means when I add, I get 0. Okay. So here's my question. Is x minus 9 a factor of this cubic function? It is. Now, here's another cool part about synthetic division. Okay? We're not done yet. I found that it's a factor, but I have not factored the cubic function. Here's another thing that synthetic division does. Is right now, I know that x minus 9 is one of my factors. Because I got a remainder of 0. Here's the other part. These numbers down here are the coefficients of 1 degree less than what you started with. So this is 1x squared minus 9x plus 14. Since I started with a cubic function, every time you do synthetic division, it drops it down a degree. That's what these numbers represent down here. Okay? And now, there's my first factor. Here's my quadratic factor that now I can either use quadratic formula, or I can try to factor. This one's factorable, so let's go ahead and finish this one off. We've got x minus 9. And if we're going to factor this, this is just your basic quadratic factoring. So, x times x. In this case, factors of 14, either 1 and 14 or 7 and 2, and hopefully you can see that it's 7 and 2 pretty quickly, and they both need to be negative in order to factor that. Which means, if I wanted to then finish this off, it's fully factored at this point. Now, that means 9 is one of my zeros. That means 7 is another one of the zeros. And that means 2 is your third one. You found the 3 zeros of your cubic function. Okay? This process, a whole lot faster than long division, but gets you to the exact same spot. Okay? Whole lot quicker. How we doing? Making some sense? Hopefully. Like I said, we struggled through long division the other day in that lesson and the long, the long process that you have to go through, so that hopefully we can kind of get to the synthetic division, which is much quicker and hopefully makes a little bit more sense. All right, let me give you another one. So first question I have for you. What's the factor, or what am I going to use for synthetic division here? What number? What do you think? The only way you think, what am I going to use here for my synthetic division? Okay? That's why I provided the graph. You're using the zeros. So -3, so what I'm checking is x plus 3 a factor? It should be, because it's on the graph, which means -3 is what I'm using for my synthetic division. Okay? Let's go through the process. Because these other 2 zeros, by the way, if you take a look, they're not the nicest things in the world. Okay? They don't happen to cross at real nice spots. So we got to be able to try to figure out where those are at. So here's our process. Bring down the 1. Multiply, I get -3. Add, I get -2. Multiply, +6. Add, I get -2. Multiply, +6. And I add, and sure enough, there's the remainder. Okay, we confirmed that it is a factor, like we knew it was off of the graph. The reason why this is a nice part is that means x plus 3 is a factor, and the other factor is sitting right here. Since I started with a cubic function, that's the coefficient of a quadratic. This is 1x squared minus 2x minus 2. So it will always give you the other factor when you go through, or the next factor, which means, like we said, this one then we've got -3 as my first zero. And the question is, what are those other ones? What would I do in order to solve for this? How would I find those other 2 zeros? Not so nice. Cal, what do you think?
Quadratic form, or quadratic form.
Yeah. In this case, you could try to factor, but it's not going to factor nicely. So you would have to use, this one would go back to the quadratic formula again. And I stole this example from last year, and I think, if I'm right on this one, I believe that your two other x-intercepts when you do this should be approximately -0.73 and approximately 2.73. Coming from the quadratic formula. Okay? If you go through and you plug everything in and you take the square root, there are your 3 real zeros. 2 of them are not very nice, but they're still real. They're still on the graph. All right, I'm gonna have you do one. See if you can take a look at this one. See if we can take a look at that one. I'll tell you, it does not not matter which 0 you pick off the graph and start with. Okay? In the end, you'll be in the same spot. Go ahead and try it, see what you get. All right, let's take a look, see what you got here. Okay, I'm gonna use x minus 4. You could have used x plus a half. Same thing, it wouldn't matter. We'll talk about both actually. We'll work our way through it. But I'm gonna start with the 4 then. So bring down the 2. Multiply, I get 8. Add, I get a positive 1. Multiply, I get 4. Add, I get a negative 4. Multiply, I get negative 16. Add, we get negative 2. Multiply, I get negative 8. And sure enough, there's my remainder of 0. I know it's a factor. Okay? So if that was where I wanted to stop, I know that x minus 4 is one factor, and this then would be a cubic. This would be 2x cubed, 1x squared, minus 4x minus 2. Remember, it's always, every time you do synthetic division, it goes down 1 degree. Okay? But if the point of this problem is I want to find all of those 4 zeros that I have, let's keep going. We can go again. Okay? Meaning? Now I'm going to use the negative 1/2 as the second factor. We can just keep the process going now with those same numbers again. Okay, with the cubic that we just came up with. Bring the 2 down. Multiply, I get negative 1. Add, I get 0. Multiply, I get 0. Add, I get a negative 4. Multiply, I get a positive 2. And sure enough, there's another 0. We just confirmed that that was also a factor. So rather than like we did before where we had to do, all right, we did long division and we got a cubic. Now I got to do long division with the cubic function. Well, we can just do a second set of synthetic division. Or if I needed to, I could do a third set. I could do a fourth set. We can do this. We can keep going as far as we want. But now, here's where we're at then. Okay? If we put this all together, that means we've got, because I used the 4 and that worked out, that means x minus 4, my first factor. Because negative 1/2 also worked out, that means x plus 1/2 is also a factor. And then we said we did it twice, so these are quadratic. Okay, these are the coefficients of a quadratic. So I have 2x squared, 0x, so I'm not even going to write that, and then minus 4. And so here's my final thing that I want you to take a look at. You could leave it like that if you wanted to, but here's another kind of nice thing. Anytime you use fractions, we have a greatest common factor here. We got 2 in both of those, right? So here's what I could do. I'm going to leave the x minus 4 alone. I could clean this up. If you left it like this, like let's say this was on the test next week and you left it like that, I would still give you credit. Okay, I'd give you full credit for that. But here's one of the nice parts. Let's say I take the 2 out of this. Let's say I factor it out. Meaning, this becomes x squared minus 2. But then, I'm going to take that 2 and distribute it through the middle one. I'm going to take it out and then put it in. Meaning, this becomes 2x plus 1. So it cleans it up a little bit. You can take that greatest common factor out of one factor and then multiply it through the other, and now you don't have any fractions. There are your factors. And now the only thing left to do would be zero product property. Set each factor equal to 0 and solve from there. How are we feeling on this stuff? Doing okay? It's a whole lot better than long division, right? A whole lot better than long division. Okay? So if you go through it, like I said, so again, how do I know when to use synthetic division? Same thing when we had long division. You can always use it. I mean, it's always an option. Okay? But same idea. When you've got more than 4 terms and you don't have any other method of factoring, then you're going to go through and be able to use it. I will tell you in advance, because I don't want you to, as you're working through this, I don't want you to get lulled into a false sense of what you're going to be able to do versus what you won't be able to do on the test. You will not have access to Desmos on the test. Okay? If there's a problem where you need a graph, we'll give you the graph. Okay? So you will not have access to Desmos on the day of the test to be able to just graph anything you want. It'll still be that, the normal calculator. All right, so here's what I want you to do then. Assignment for today is, I've got just a synthetic division worksheet, and it should go fairly quick, okay? As you work your way through, as you can see, we just went through 3-4 problems. It's not a super long worksheet. And then, again, there is a Delta Math assignment with some synthetic division, just some practice in there as well, okay? And that is right there. That's the end of the chapter at that point.